Hi everyone, in this video we'll be solving another Leetcode problem, valid palindrome 2. So we are given with a string and we have to return true if the given string can become palindrome if we can delete one character or zero character from it. So at most one means 0 or 1. So there are a couple of examples given. So first example is ABA. This string is in itself a palindrome, so we don't have to delete any character. So that's why we return true. ABA. So this is a palindrome. Another example ABCA. This is not a palindrome. A and A are same. We can delete B or C to make it a palindrome. So this can become palindrome by deleting any of the character B or C. We can take any character and delete. That's why we'll return true, because we can delete at most one character and we may choose B or C. Last example, all the three characters are different. That's why it's not possible to delete one character and then make it a palindrome. So this is the problem. Let's see how we can approach and solve this problem. Let's take the first example where we don't have to delete anything. The string itself is a palindrome. So let's take M A D A M. This is a string which is palindrome. We don't have to delete any character to make it a palindrome. So how do we check if a string is palindrome? We take two pointers. One is called left and one is called right. Left is taken at the beginning and right is at the very end of the string, last character of the string. We compare the characters present at left and right, which means that we'll check S of L equal to S of R, and if they are equal we move towards the center. We'll move L to point to A and R to point to another A. So this is the new position of left and right. We will continue until left and right are equal. If they are equal and we don't see any mismatch, which means that the string was palindrome. Now we'll take another example where there will be one character which needs to be deleted to make a string palindrome. So let's take another example. A, B, C, D, then D, C, X, B and A. Now here we have a character which needs to be deleted to make this whole string palindrome. We'll follow the same approach. We'll take left and right. These are equal. We'll move towards the center. These two are also equal. Now we'll compare C and X. Now C and X are not equal. Now what we can do is we can delete either C or X and then check if the remaining portion is palindrome or not. So what we can do is we can take either this portion, or which means that I have deleted the character which was present at S of R. And second condition is we can take this string and then compare if this remaining portion is palindrome or not, which means that we'll check L to R minus 1 or L plus 1 to R. So these are the two remaining portions that we can check, and we are deleting either the character which is present at the left position or at the right position. If one of the portion, either this one or this one, is a palindrome, which means that we deleted one character either at the left or at the right and the string became palindrome. That's what we wanted, right? So this is how we'll follow. We'll take two pointers at left and right. We'll keep on comparing the character at both the ends and we'll move toward the center if the character are same. If they are not same, we'll compare from L to R minus 1 or L plus 1 to R. That's because anything towards the left of L is already palindrome. We have already compared this portion and this portion. So this we have already confirmed that these two are already following the property of palindrome. So we don't have to take care of this one. Whatever is left, we'll compare only that portion. That too, deleting the character which is at the left, L plus 1 means that we have neglected the character which was present at S of L. L2 R minus 1 means that we have discarded the character which was present at R. We have skipped this one. And in this case, it turns out that this will become a palindrome. So in this case, we should return true. If there are multiple characters that needs to be deleted, this logic will fail and will return false in that case. Let's say another example: A, B, X, C, D, B, C, Y, B, A. Again, here also we'll compare this and this, same, this and this, same. Now we'll compare X and Y. These are not same. We'll take this portion. This is also not palindrome. Or we'll take this portion. This is also not palindrome. That's why we'll return false. We can take edge cases also, like if a string has only two characters, in that case it will also work. If we delete either one of the character, a single character is always a palindrome, so that also works fine. So this is how we can follow. You can think of multiple inputs, like if a string is empty, 2 character, 3 character, and so on, and try to simulate this one and see if it works or not. So we'll go back to Leetcode and code this up. We saw that we can take 2 pointers left and right and move towards the center, comparing each and every character which is at left and right position, and in case of mismatch we discard one character either at the left or at the right. So we'll take 2 pointers, left equal to 0 which is at the beginning of the character, and then this is at the end of the character, and the condition should be until left and right are not equal, which means that there are some character that still needs to be compared. And we'll compare if s of left not equal to s of right. Now here we found that there is mismatch in the character in left and right position, so we has to do something here, and at the end we has to do left plus 1 and right minus 1 to move towards the center, and in the end we has to return true if we don't found further mismatches apart from the single one that we found here. And here also we'll return something. As we discussed, if we find a mismatch, we can compare either from left to r minus 1 or left plus 1 to r. So we'll create another function which is doing nothing but comparing if a string is palindrome or not, but within a range. So we'll send L, we'll send string s left and right minus 1 or same left plus 1 to right. We have two options, either from left to right minus 1, which means that we have discarded the character which was present at the right, and in this left plus 1 to right, which means that we have discarded the character present at the left. We can define this function. This will be a direct function to check if the string is palindrome or not. So L less than R if s of L is not equal to s of R, then s of L is not equal to s of R, then s of L is not equal to s of R. If s of L is not equal to s of R, then s of L is not equal to s of R. If s of L is not equal to s of R, then s of L is not equal to s of R. If s of L is not equal to s of R, then s of L is not equal to s of R. If s of L is not equal to s of R, then s of L is not equal to s of R. If s of L is not equal to s of R, then s of L is not equal to s of R. If s of L is not equal to s of R, then s of L is not equal to s of R. If s of L is not equal to s of R, then s of L is not equal to s of R. If s of L is not equal to s of R, then s of L is not equal to s of R. If s of L is not equal to s of R, then s of L is not equal to s of R. If s of L is not equal to s of R, then s of L is not equal to s of R. If s of L is not equal to s of R, then s of L is not equal to s of R return false, which means that this is not a palindrome. Otherwise, left plus equal to right minus equal to return true. That's it. This function is just checking if a string is palindrome or not within left and right positions, because anything left of left pointer and anything right of right pointer we have already checked, and they turned out to be palindrome. That's why we are calling this function. It won't be a case we'll find another mismatch, because as soon as we find first mismatch we'll be calling this function and we'll be returning. Now either of these two conditions should be true to return true from this function, because we have OR condition. Now let's try to run this. Good. Accepted. This works. Now we can see what is the complexity. So we have two things, time. So let's take what is the time complexity. We are running loop here from left and right and moves towards the center. So we are bounded by the length of the string. Whatever is the length of the string is our time complexity. We are processing in terms of length of the string. That's why the time complexity should be order of n, and the space complexity will be order of 1, because we are not taking any additional space. We are just taking some variables left, right, and the above function we are taking some variables. That's why we are not taking any space corresponding to the input. That's why the space complexity is order of 1. So this works. There is one observation that we can see is this function and the other function that we have created is almost same. We are just taking two pointers at the end and then moving towards the center and comparing the character. So there is an scope of improvement in the code reuse. So what we can do is we can try to use this function only and merge whatever is in this one. So what we'll do, we'll call that function only. We can call this function, but from 0 to len of s minus 1. But the problem here is we has to take care of the mismatches also. Let's delete this one. We has to take care of the mismatches also. And we can allow mismatch only once. That's why what we can do is we can take mismatches equal to 0, because for the first time we don't have any mismatch. That's why we can take a default value of 0. And in other cases, if mismatch is more than 1, then we know we have to return false, because we cannot allow more than one mismatches. And here, if we found the first mismatch, what we can do is we can call this function L2 R minus 1, and mismatches will be incremented by 1. If it was 0, then we'll increment it by 1. And the same here that we did in the last function is palindrome S2 L plus 1 to R and mismatches plus 1. So we are doing the same thing. We have just reused the code and we have taken care of the mismatches, because only one mismatch is allowed. That's it. I think that should work. We have taken a default value of 0 and then plus 1 plus 1. Yeah, it should work, and OR condition. So everything remains same. We have reused this function and taken care of the number of mismatches that we have encountered. Submit. This is also accepted. So time and space complexity remains the same. We have just reused the code instead of writing the same function again and again, which has slight differences in the functionality. We have taken another variable to handle that number of mismatches, and everything remains same. So that's it for this video. See you in the next one. Bye.